Hi, I'm Dr. Papia Bhattacharjee. In this problem, we have to find the least squares regression line for these 3 points. Also, we have to plot these points and the line on our xy coordinate plane. So, first notice that the points are -2, -1. So, this is our point -2, -1. Then we have the origin 0, 0, and we have 2, 3 right here. Okay, so the points are right here, and we have to find the least square regression line. Okay, so suppose the line is y equals ax plus b. Now, what is a least square regression line? This is a general form of the line. Now, what do we have to figure out? Of course, we have to find a and b, but what conditions do we need? So, we need to find a and b so that the error, the sum of squared error, has to be minimum. Okay, so notice it's a minimizing problem. So we have to first find the function, and the function can be found using the sum of squared error formula, and then we have to minimize that function. That will give us our a and b, so we will know what line it is. Okay, now recall the definition of the sum. So the definition is we have to take the difference of the function values and the actual y value given a point x1, y1 and square that, and then we have to add each term this way for each point. Now look, there are 3 points, so we'll have 3 terms like this. So next one will be f of x2 minus y2 square, and then lastly f of x3 minus y3 square. Okay, so what is fx? Of course, our function is right here. This is our fx, right? And then these points x1, y1, x2, y2, and x3, y3, they're right here, right? Okay, so this is x1, y1, x2, y2, x3, y3. Okay, so let's rewrite this expression using our function and the points. So what is f of x1? x1 is -2. Plug that in this expression. So we get -2a plus b. And then y1 is -1. So this is minus of -1. And the whole thing has to be squared. Okay, let's compute the second term now. Okay, fx is right here, x2 is 0, plug that in, so you just get b, minus y2 is 0. So that thing squared. And finally, x3 is 2, plug it in the function, so we have 2a plus b, minus y3 is 3. That's squared. Okay, so this is our expression for s. Now we have to expand it, because remember we have to compute the partial derivatives with respect to a and b, right? So in order to expand, you just have to FOIL, and you know how to FOIL. Okay, so I have already expanded, and the form that we get is 8a squared plus 3b squared minus 16a minus 4b plus 10. All right, we have our expression for s. Remember, that's the function that we have to minimize. Okay, so let's find the partial derivative of s with respect to, the variables are a and b. So to compute the derivative with respect to a, so b is constant, right? So from the first term, the derivative is 8 times 2a, so 16a. This one is 0. Third term is negative 16. And then the rest of them, the derivative will be 0. Okay, then what about the partial with respect to b? Now the first term derivative is 0, then 3 times 2b, so it's 6b, then 0, then negative 4, and 0 again. All right? These are the partials. Set them equal to 0 and solve, and we get the critical numbers. Okay, so from the first one, we get 16a is equal to 16, which means a is equal to 1. From this one, we get 6b is equal to 4. That means b is equal to 4 over 6, but that's same as 2/3. So our critical number is 1 and 2/3. If you want, you can quickly check if this will give us a minimum for the function. You can do a second partial test if you want. So quickly, let's do it here. So what about the second derivative? So let's say SAA, okay, and that's 16. That's the derivative of this expression with respect to A. Then SBB is the second expression with respect to B, that's just 6. And then SAB, the first expression with respect to B is 0. And you see that SAA is positive, and when you compute D, that is SAA SBB minus SAB square, that's just 16 times 6 minus 0, and 16 times 6 is also positive. So if these two are positive, you get minimum. So minimum S. Okay. Now, what do we want? We want to find this line, equation of the line. And we already have the value of A and B. So the least squares regression line is y is equal to A is 1, so x plus b is 2/3. Okay, if you use this line as a model to fit these points, okay, the best fit is this line because the error is minimum. All right, finally, we just have to grab that line on the same coordinate plane, and the points are already there. So notice you can easily figure out 2 points on this line. If you plug in x equals 0, y will be 2/3. That's the y-intercept. So say somewhere 0, 2/3, somewhere here. And then if you plug in x equals negative 2/3, you get y equals 0. So that's the x-intercept. And negative 2/3 is somewhere here. And you can draw the line through these 2 points. So we have plotted the points and the least square regression line. Thank you.